Okay, today our first topic is matrix algebra. Matrix algebra is chapter 1 under the linear algebra, block 2 for the paper code MEC-203 quantitative methods in economics. Okay, so though the most of the textbook on matrix and the determinant, they first discuss about the matrix and then discuss determinants, but our English study material follows historical background and they discuss at the first determinants and then about the matrix. Okay, so today our first topic is determinants. Let's see the definition concept of determinants. So we have assumed the two linear equation in one variable a1x plus b1 equal to 0, a2x plus b2 equal to 0. So then uh, assume that a1 b1 a2 b2, these terms are non-zeros, right, and have the same and common solution. Then we can write it as follow: a1 by a2 equal to b1 by b2, and that is a1 by b1 equal to a2 by b2. And also we can write a1 b2 minus a2 b1 equal to 0, and this expression is called actually the determinant and is denoted by as this symbol. So this symbol actually determinant. And and this a1 b1 and a2 b2 are the element of this determinant. Okay, along the vertical axis we see the column, actually direction of column, and along the horizontal axis the direction of the rows. So as we have two rows, two column for this determinant, so this is a second order determinant actually. And again, if we take the three linear equation in two variable, uh, this a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, and a3x plus b3y plus c3 equal to 0. Okay, this is our first equation, this is second equation, and this is our third equation, right? So then uh, we assume that have the common solution, then by the cross multiplication from the last two equations, from the equation 2 and equation 3, we can easily find out the value of the x and y, and where this uh, common term a2 b3 minus a3 b2 is not equal to 0, right? So for the solution to be common, so these values of x and y, just put the equation 1. Okay, then we have this expression a1 b2 c3 minus a1 b3 c2 plus a3 b1 c2 minus a2 b1 c3 plus a2 b3 c1 minus a3 b2 c1. So this expression, like the above, for the two linear equation, uh, we denoted it like this, symbolize of determinant second order. And also for the three linear equation, this expression we can determine symbolize like this, right? So here we have the three column and three row, so this is the third order determinant. Okay, so rule for determining the sign of involved terms in the expansion of 3 by 3 determinant. So we just write the three column of determinants twice. So write ABC PQR XYZ, and again write ABC PQR XYZ. Okay, and take from the left to right, just multiply this term and add them. So adding them, AQZ plus BRX plus CPY, and then minus from the right to left arrow terms, multiply those, we have minus ARY minus BPZ minus CQX. Okay, so okay, so actually this determinant we can express like this: a1 times, so a1 is contain the first row and the first column, so do not take any value from first row and first column, so just remove this, and we have b2 c2 b3 c3 right? And for the b1 minus b1, just remove the first row and the first column. We have a2 c2 and a3 c3 value, right? And plus c1. For the c1, remove the first row and third column. We have the value a2 b2 and a3 b3, right? And this expression we can write as follow this. Okay, so application of determinant, we can for as an example, the Jacobian determinant. So Jacobian determinant is actually an essential tool for the mathematical analysis. So in the determinant form, Jacobian determinant, we can write this: the partial derivative of u respect to x and partial derivative u respect to y, and again the partial derivative of b with respect to x and partial derivative of b with respect to y. So just multiply this. So from right to left, del u del x times del b del y, and left to right, so here will be the minus sign, del u del y times del v del x. So where u and v are the two given function of x and y, so each term as the Jacobian of ub with respect to x and y. Often we can write this as follow: del u del v by del x del y. Okay, and similarly for the three function, we can write our Jacobian matrix as follow: del u vw by del x y z. Okay, so this is actually the third order Jacobian of u v and w as a function of x y z, right?